Good morning, students. Hello, am I audible?
Good morning, sir.
Good morning, sir.
Good
So,
morning, sir.
let,
Good morning, sir.
let's morning. Let's start it. Yesterday, very sorry that power cut was there, and that has been revived around evening. It was not possible for us, so we will adjust this total time today. We will take one hour and 35 minutes today. Now let's start. We are discussing about that knapsack problem and the last method, the optimal solution we are discussing about. So we'll continue with that. Then we'll start with other things. Just a second. Let me share it. Just a second. So I think my copy is visible. So now we had a discussion regarding that. So calculation has been made that profit by weight ratio. So please tell me item column is there, unit, profit, and remaining weight. So just tell me from the previous day what was the profit ratio. I1, tell me, P1 by W1, 5. What has done on last day? Hello? Hello? Can you hear me, Pritam? Hello? Can you hear me, Pritam?
Sorry, sir. My mic was mute. Sir, we were doing maximum ratio for first to last.
Yes. So what was the ratio? The I3 is equal to 3. Then tell me, forward this one. I4 is equal to what? 1.
Yes, sir.
I5,
I5 4
4.
and I6 1.
I5, 4 or 4? Just a second. It was the
Wait, though,
I1.
sir.
No, sir, this is not
Sir.
wait.
Sorry, sir. Ratio.
Yes.
I5 C,
5,
I5 6 and
I5,
I4
6.
1, I5 6. Yes.
I6 is 4.5.
Yes.
I7, 3.
And
3.
I7 3.
Yes. So whatever we have taken, first one is 6. I5,
Yes, sir.
1 unit. Profit is, for I5, profit is what? 6.
6.
Then remaining weight is 14 minus 1 is equal to 13. Isn't it? एक बार check करो तो.
Sir, 15 minus 1, 14.
15 was the word, na? Yes. Sorry. Perfect. 14. Then next is
I1.
I1 1 unit. Profit is 10. Remaining weight is 14 minus 2. Is that okay? Is that okay or not?
Yes, yes, sir. Wait is okay.
Now next one is which one?
I6.
Profit is 18. 12 minus 4 is equal to 8. Next is 3. I3. Then I7. Now 2 unit. Next is I2. No. Most probably I had made any mistake. No, it's okay. Then I2 1 unit cannot be taken because 3 units are there. We have only 2 units remain there. So it has to be calculated in that way. If we can take 3 unit, profit will be 5. If we can take 1 unit, profit will be 5 by 3. If we can 2 units, then 10 by 3 is equal to 3.33. So it can be taken 2 by 3 unit. Profit is 3. Profit is equal to what? What will be the value? Calculate this one. What will be the value? Pritam, Samata, can you listen? Hear me? Hello?
Sir, 41.
Am I audible to all of you? Hello?
Yes, sir. Audible.
So, how this will be 41? This will be
Oh,
added.
profit. Sorry, sir. Profit. I calculated it.
Something like that. Yes,
So 55.33.
55.33. Okay, so this is the best one. Just compare with the previous two. Compare with the previous two.
Yes, sir. Previous one
This
was
is,
54 and before that
yes,
47.
this is the optimal solution. So, it's based on the marks provided in your question. If it provides you 10 marks, then you have to go for all these 3 solutions for calculating the optimal solution. Now, if they are providing you 5 marks, then only the third one. You will go for the third one only. That last one. Profit by weight ratio. So it's based on your based on the number of marks they have provided, and this is very important. If you can see your question paper, it's in almost every semester. One problem will be there from knapsack problem, And this solution is by greedy algorithm. Another solution is there by dynamic programming. So if we got time, if we have time later on, we'll go for that. But this is the more widely popular solution, and you have to go for that. And this is 0 1 knapsack. Means either we have taken the item or we have not. Sorry, sorry. This is fractional knapsack. Means if we cannot take the whole item, we can take a part of it. And another knapsack solution is there, 0 1. This is very simple. 0 1 means if the total item cannot be taken, then we will not take the item. And some portion of the bag may be empty in that cases. So this one was 0 1 knapsack, and this is fractional. And fractional is the most important. You will get fractional knapsack problem most of the time in your question.
Sir,
So any yes. What so?
sir, the product by weight ratio.
Profit by weight ratio, not the
Yes, I'm
product.
sorry. Profit by weight ratio.
This one is the optimal solution. We have done that one, profit by weight ratio. Here, based on this profit by weight ratio, we have arranged the items.
Okay, both are same.
Which one?
Profit and weight ratio and fractional one.
No, fractional one means whatever we are doing. Fractional one means it may be that increasing order of weight or decreasing order of profit. All these are fractional, because just see whatever done in the previous thing, because I have done this one in computer yesterday.
Yes, sir.
So I do not have this one, but just go for the previous two solutions. This was again over there also we have taken a fraction of that element, last item. Just go through it.
Okay.
We have not taken the full item for the last item because the space was not there in the bag. The capacity was not there in the bag. If we can take 2 by 3 part of the item, we can take that one. But in
Sir,
0
sir,
1
sir,
knapsack, we will not take this one.
sir,
Yes.
excuse me. Sir, the first one you have said that non-increasing order of profit.
Yes.
Second one was non-decreasing order
Decreasing
of
order
weight.
of weight. Yes.
And third one was profit
Profit
by
by
weight
weight
ratio.
ratio. Yes.
And this is the fourth one.
No, this is the third one. Just we have continued the yesterday's method, whatever not completed.
Okay, this is the profit and weight ratio
Profit.
only.
This one, profit by weight ratio.
Okay. Okay, sir.
So only three methods are there. Last one is the optimal.
Yes,
And
sir.
this one, all these three methods we have followed are fractional knapsack. 0 1 means
Okay.
either the total item can be taken or no item will be taken. If the space is not there, if the capacity is not there, if the capacity is exhausted, then we will not be able to take any fractional part. Either the total item will be taken or no item will be taken. For that, this is called 0 1. Either no item will be taken, 0 item, or the full item will be taken. And fractional, whatever may be possible, the broken items can be taken. Okay.
Yes, sir.
Another greedy method is there, very important greedy method. This is the cassette or tape filling problem. Cassette or tape. Cassette or tape filling problem. So here the thing is that, have you any idea about the audio cassette? Did you have any idea about audio cassette for listening
Yes, sir.
music? Have you seen that one?
Yes,
So
sir.
today it has been it's become obsoleted actually.
Yes, sir.
But in cassette, if you can remember, if you have seen that one. So if we
Yes, sir.
want to listen the last music, the actually musics are stored over the track, and two tracks are there, parallel tracks. Songs are stored over that track. So if we want to listen the third song, we have to go through first two, isn't it? Directly we cannot go to the third one. This is not possible.
Yes, sir.
So here, suppose I have three songs A, B, C, and here for A this is 5 minutes time, B for 4, and C for 6. Suppose now in which order? This A, B, C can be arranged by which minimum average waiting time will be there?
BAC.
How you can told that one directly? We have to calculate
Sir, minimum
average
waiting average.
waiting time. So suppose I am arranging it ABC order.
Yes, sir.
At the same time, A, B, and C comes into the system, and so here waiting time will be first waiting time for A. It has comes to the system and immediately allocated. So 0 waiting time plus next is B. It waits till the A has completed. So 5 plus C waits for A and B. Whenever A and B completed, then C has completed. So 5 plus 4. Is that clear?
Yes, sir.
Is equal to what? 14. So average waiting time will be 14 divided by 3 is equal to some value. Similarly, another combination is possible, BAC, as you have already told. In that way, something. What will be the value for BAC? Tell me.
B. Sir,
First, B comes to the system and allocated. For B, waiting time is 0. For A, it waits for B. So 4. Plus C, it waits for A and B. 13 divided by 3 average waiting time. In that way, how many combinations are possible with these three songs? How many combinations are possible?
9, sir.
No. How 9 combinations? Tell me.
Sir, 8.
How 8? What will be the combinations? Tell me.
A, B, C, B, C, A,
Yes,
C,
in that way.
A, B, and
2 to the power 3.
Max to max 6 combinations will be possible. Calculate it.
okay. A, B, C, B, A, C, A, and C, A, B, and C, B, A, B, A, C, B, A, C, and A, C, B. Okay.
No other combinations are possible.
Yes, sir.
So 6 combinations. So in that way, I think this we will be able to do that one. No issue. So this is a small question, maybe there 2 marks question or 3 marks question, that average waiting time for cassette or tape. So this is also greedy method, because here we have a number of combinations, but we have to choose the best one. So this is also the greedy method.
Yes, sir.
Now these two problems has been solved. Now come to sorting part. One or two questions may be there. One full question will be there from sorting, calculating the complexity. At least we have to do. We have to calculate complexity for insertion sort. Bubble bubble sort, merge sort, and quick sort. These are widely popular sorting algorithms, and you have to know how to calculate the complexity, time complexity of these sorting algorithms. Along with that, sorting algorithms are also important. Both the full question, you will get at least one full question from this part, 15 marks. So this is the very important part of algorithm. So let's start it with bubble sort. What is the mechanism of bubble sort? The sorting will be done. Tell me, you have already done it. What is the mechanism of bubble sort?
Sir, the one by one we have to check the which one is greater.
Okay.
We have to put that one um, at the last,
How?
and the
Suppose tell me.
least one
Okay,
is the first,
I'm coming for one
from
example.
left to right.
Suppose we have items in the array 30, 52, 29, 87, 63, 27, 19, 54. Suppose we have these elements. So what will be the situation after first pass? What will be the steps?
52. So 30, 52 comparison.
Yes, 30 and 52 will be compared. Step A,
And
compare 30 and 52. Since 30 less than 52, no swapping. Am I clear?
yes, sir.
Then step B, compare what?
52, 52 and 29.
This will be the situation of the array. Then compare 52 and 87. In that way. Any confusion, all of you?
No, sir.
So in that way, in why this is called bubble? Because it's like bubble. The nature of bubble is to comes from down to upwards of the water. So here also in every pass, one item will be there in the sorted position. If we are
Sir,
yes,
sir, after sorting 30, 29, 52 is there.
yes. After the first pass, actually you have started the pass one.
Yes,
After
sir.
first pass, this will be in that way will continue and 30, 29, 52,
Yes, sir.
63,
Yes, sir.
27, 19, 54, 87. So this becomes sorted. One
Yes,
item will
sir.
be sorted.
After that,
After
yes,
that,
sir.
again, we will start from the beginning on the pass two.
Okay.
Again, 29, compare 40 and 29. In that way, again, we have to continue. Since 40 greater than 29, show swapping. Swapping
Yes,
is
sir.
done.
It is in the next phase.
Yes, next pass. Next pass. So
Next
in that
pass.
way,
Okay.
gradually this will be decreasing, and on every pass, one item will be sorted, and we will
Mm.
get the sorted items.
Okay.
So that means here, if you can see that one, here first is n minus one comparisons. Okay, first item has been compared, and one item will be sorted. On the next pass, n minus two items will be compared, n minus 3 items will be compared. In that way, last one item will be compared, isn't it?
Yes, sir.
So this will be the total time requirement. Time requirement that will be is equal to, this is one mathematical expression actually, that will be n into n minus 1 by 2 is equal to n square by 2 minus n by 2. Now if n is greater than 0, that means suppose 1 lakh elements, 2 lakh elements, then this item can be avoided, neglected. This can be neglected. So complexity will be big O of n square.
Sir, can you explain once again, please?
First, for the first sorted item, on the first pass,
Yes, sir.
the every item will be compared with others. So maximum n number of one comparisons, because first item we have already taken, and then rest of the elements n minus 1. Okay, and one item has
Okay.
become sorted.
Mm.
On the next pass, so this item we have discarded, so n minus 2 comparisons will be there,
Mm.
then n minus 3 comparisons will be there. In that way, for the last item, one comparison will be there. Okay,
Okay, sir.
so this is one mathematical formula, actually expression, that will be n
Okay.
into n minus 1 by 2. So
Two.
this will be n square by 2 by minus n by 2. Now if the n value is very large, then n
Yes,
will
sir.
become very small in comparison with n square, isn't it?
Mm. Yes,
So
sir.
in that cases, so n square depends on n square, so complexity is big of n square.
Okay. Yes, sir. Okay.
This is the complexity of bubble sort.
Yes, sir.
Now, if in case of insertion sort, this becomes very large.
Sir, can you show the that one for first sum? Yes, once again. N minus one. Okay. Yes, sir. Yes, sir. Okay.
So in case of insertion sort, first of all, the mechanism has to be understood. What is the mechanism for insertion sort? What is the mechanism? Complexity we are coming, but what is the mechanism for insertion sort? First tell me. Hey, what about others? Whether they are in the meeting or not, I don't know. Whether only the mobile or computer has been switched on and joined the meeting and then go for some other purposes or not, I don't know. What about others? No one is responding. Hello?
Yes, sir. I don't know.
What about others? Let's see.
Okay.
What's the situation over there? Pritam, are you there? Rose?
Yes, sir.
Shudhangshu? They are just maintaining the attendance. Sujit?
Yes, sir.
Okay. Now tell me, what is the mechanism of insertion sort? This is already done. This has already done in
Data structures.
Yes. So again the same, suppose same items are there. 39, 9, suppose these items are there. 45, then anything. 63, 18, 81, 108, 54, 72, 36. We have these items. Suppose. Suppose these items are there. Can you see that one?
Yes, sir.
39, 9, 45, 63, 18, 81, 108, 54, 72, 36. Now, what will be the situation in insertion sort? What will be the pass one? What is the mechanism before? This is a very simple sorting algorithm in which the sorted array is built one element at a time. So in every pass, one item will become the sorted item.
Sir, we compare the two items and the lowest value will move to the left. First means first
What will
index.
be the yes? What will be the situation of what will be the situation after first pass? 39, 9, 45. Okay, sorry. First, these two items will be compared. 9 will comes over here. 9, 39, 45, 63, 18. All these items. 9 will become the sorted item. Then on the next pass,
54. 9:45. No, 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 no.
39:45. From starting from 39:45, then 13
yes,
that position will be sorted after that 45 position.
yes.
Means that
So that
index
means it will become 9, 18,
18.
then 39,
9,
45 in that
18,
way.
39, 45, 54, 63, 81, 81, 108. No, 60.
Whether I have to write down all the passes,
Sir,
I
please
can
write
write
once.
down. So do it in that way then. We have the array. We have these elements. On the first pass, pass 9 will be swapped with 39. Then rest of the elements will be same. Next pass, 39 in the pass 2, 9, 39 will not be changed because 45 is there. 39 will be compared with 45. So no changes will be made. Clear?
So,
Then on the pass 3, again no changes will be there. 45 and 63 will be compared. So no changes will be there. On the pass 4, on the pass 4, 9, 18. Now it will be changed. 39 and 18 will be changed.
So 63 and 18.
In that way, now. This is past 4, past 3.
9, 18, 39,
39, 45, 63.
45, 63, 81.
Exactly. In that way, this will be continued. So in every
Yes.
pass, one item will be sorted. In every pass, one item will be sorted. If we are coming to the algorithm part, algorithm is very important over here.
3.
Suppose this is the array. Step 1 will be for j is equal to 2. We are starting from the next item. Second item, 2 length of A. We are taking one key value. Key is equal to first, second one, suppose A of j. Insert A of j into sorted sequence.
Sir,
Hmm?
so the fifth, sixth, seventh. The seventh pass will be 9, 18, 39, 45. Then
9, 18,
54.
39, 45, 54, 63, 81, 100, 72, 38, 36.
Okay. 4, 63, 81, 8.
This will be the total algorithm. Now we have to calculate complexity, and it's very large actually. We'll go for that today.
So the algorithm, can you explain? Will you explain, please?
This is very simple. We are taking from the second item. So we have started from j up to the length, up to last element. We are continuing. Now we are taking one key value. Second become the key value. First one we have
Yes, sir.
already took that one, and we'll compare. And this second value is continuing actually. Now insert a of j, that means this value, second item, if this is the smaller, this is smaller than the previous one, we insert that one into inserted sequence. If this is second item is smaller than the first one, and the rest of the thing. Now I is equal to j minus 1. Again here j, whatever may be the value, we put that one. I is equal to j minus 1 means previous one. Now while I greater than 0 and a of I greater than key, that means we have to continue. From here we are continuing which item is smaller than that one. If any item is smaller than that one, we are swapping this one, isn't it? So
Yes, sir.
while I greater than 0, that means more than one items are there, more than one elements are there. If only we have one element, then it's no question of sorting. It's already sorted. So if it has to be more than one, zero element, and if the value is, the next value is greater than key means that whatever we have taken, second one. So if this is greater than that, we will swap. How this will be swapped? I plus 1 is equal to I. That means we have to first create the space over here. We will shift all the items on the right, and this item will be inserted at that place. This one. This is for shifting and this is for inserting. Because
Okay.
first of all, you have to create the space. All the items will be shifted right, and then this inside this place, the item which will be sorted, this will be placed on that place. You have done in that way.
Sir, we have to write the steps do the first step that you have underlined, and the second step you have underlined alternatively again and again
This
in the
is already
algorithm.
iterative while. Obviously, no, they don't have to write down. You
Okay.
have already provided in a while loop. So this will be continued automatically up to last element. So
Okay.
here we have to calculate the time complexity, and this is very important. This is huge, very large technique is there. I am coming to that point.
Sir, can you show the algorithm
Yes,
clearly
yes.
once again so that I can note it down?
Is it visible?
No, sir.
It's not visible.
No, sir.
No, is that visible?
Sir, wait for 1 minute. Don't shake. Yes, sir, it's visible now. The first, so what is the first step?
Just first step is for j is equal to 2 to length of a.
1G get to length of A. Do key AJ. So third step, this.
Insert.
So third
Insert
step,
a of j.
insert.
Yes, insert a of j into sorted sequence. Insert. Just make this thing understood. I will post this one in your group.
Okay,
I
sir.
have the notes. I will post it. Don't waste time now. Just
Okay.
whether this is understandable or not, I will post. Right now, I will post it. Just a minute.
Okay, sir.
So 1 minute.
Sir, if we are asked to calculate only complexity, then will we have to write the
No, no, you don't
algorithm
have to write
also?
down. I am just calculating complexity. You will be easily understood that whether this has to be written or not. Because
Okay,
every
okay, sir.
step, for every step, we have to calculate the time. Just a minute. Provide me 1 second time. I will just change my mobile. Now first make one chart. On the first column, we will write down the expression and cost, some constant value and time. This time we have not done this one for the sequential statements, only one sequential statement we have done still now. We have to do that one, but for the timing, just whatever I will say over here, you will just assume that one. Because only in the control statements, only one thing we have done, that sequential statements, not the other thing. For the for loop, what is the time requirement for the while loop? Still now we have not done that one. We will do that one today on the second half. Now first step was what? For j is equal to 2, j is equal to 2, for j is equal to 2 length of A. Suppose cost C1, anything arbitrarily I am taking the constant value, and this step will continue n times or not.
J equal
Times will
to
be there.
length.
Almost 8, actually almost n, or that will take the n minus 1 times. So it can be taken as n, no issue. 2. Second step was do key A of j. The second step was that. Say, for example, cost for C2 we have taken, and this will continue n minus 1 times. Are you agreed or not? Oh, just a minute. I think this is not visible. Is that visible now? Is it visible now?
2. Okay, sir.
Now on the third step, what
So
was the third
second
step?
step
If you will
time.
check. Second step time n minus 1, because it will continue n minus 1 time. For the, you will leave the first item. No? First item already you have taken. So from the next item up to n minus 1, so it will take n minus 1 time.
Okay.
Third step was what? Insert A of j in that way. Insert A of j into sequence. So here cost will be 0, because for the insertion no costs are required, and it will continue n minus 1. I am just providing. Are you in the WhatsApp group, all of you?
Yes, sir, I am.
So okay, I am providing the diagram over there. It will be more clearer in that case. Just a second, and it will take
Okay.
faster. I have already made this one for you. Just a second. Posted. Got it?
Yes, sir.
So here, just I have written this. I have just written the algorithm and calculate the time. On the fourth step, I is equal to j minus 1. Cost is suppose for C4, because insertion will not take any time. So for that reason, for the insertion, we have taken that cost is 0, and it will continue n minus 1 times. On the fourth step, I is equal to j minus 1 cos C4, and it will again continue n minus 1 times because this is inside the loop. Are you getting my point?
Yes, sir.
Then fifth step, while I greater than 0 and a greater than key, this will continue how many times? 2 to n, 2 to n, because already we have started with 2 and up to length. So 2 to n. For that summation j is equal to 2 to n t of j. And on the sixth step, again this is inside the loop while, so this will continue. Tj minus 1 or Tj, it will be same because we have started from 2. For that we have taken the Tj minus 1 or Tj minus 1 or Tj, it will same almost. And I is equal to I minus 1 every time. This will be continue again Tj minus 1. J is equal to 2 to n. And insertion of key will take n minus 1 times because from the, you will start from 0 and it will take up to n minus 1 times. Is that clear?
No, sir.
Which one?
The C7 one.
I is equal to I minus 1 algorithm, it's there in the algorithm. I am just sharing the algorithm also. We have just write down the steps of algorithm, nothing else. Any question? Then very long calculations will be there. We'll come to the calculation part then. Whether if these steps are clear. Any question? Let's ask me if any problems are there, if any confusion is there.
So the eighth number.
Eighth number again inside the loop. Just go to the eighth step in the algorithm. This is inside the loop. And how long it will be continued? I greater than 0 to key, while I greater than 0 and a of j greater than key. That means it has to be continued for all the elements, na, from the second onwards, isn't it?
Yes, sir.
It has to be continued from second onwards up to the last element, isn't it? So obviously n minus 1, because n number of elements are there and we have started from the second element. So n minus 1. Clear? We have started from 2 length. So that means
Yes,
it
sir.
will be continued n minus 1. Just keeping the first element. So this is the total. Now we have to calculate the time requirement. Now this calculation has to be done now. Whether I will continue with the calculation
Okay.
or any question. No questions are there?
No, sir.
Okay. So let's start with the calculation part now. Now, calculation is easy. Actually, it's very long calculation. The running time of the algorithm is the sum of running times for each statement, whatever we have executed over here. So whatever we have executed over here. So now total time will be T of n is equal to C1 into n plus C2 into n minus 1 plus C4 into n minus 1. Just calculate this one. C5 into sum of j is equal to 2 to n T of j plus C6 sum of j is equal to 2 to n Tj minus 1 plus C7 j is equal to 2 to n Tj minus 1 plus C8 into n minus 1. Done. We have just multiplied. Simple multiplication, nothing else. Simple multiplication.
So it's not visible.
I think this is visible now.
C and
Cn is equal to C1n plus C2 n minus 1 plus C4. Just multiplication, nothing else. You have already the table.
so C4 minus 1 after the C5
Into whatever calculated C5 time requirement is what? J is equal to 2
into
to
J
n
minus
Tj.
1
This is the simple
TJ
multiplication.
plus C6 TJ. So C8 into n minus 1.
C8 into n minus 1 because n minus 1 times into C8
Yes, sir.
cost.
Yes, sir.
So now tell me one thing. Now,
Yes, sir.
now what will be the best case of any sorting algorithm? If the items are already sorted, we don't have to change anything and this will take the minimum time. Am I right? So
Yes, sir.
best case
Insertion
occurs,
sort.
best case occurs if the array is already sorted. For each j is equal to 2, 3, 4, etc. up to n elements. Okay. So that means in that cases, what will be the situation? In that case, if we are taking the best case, the situation will be Tj is equal to 1 for j is equal to 2, 3, etc. up to n. So T of n in that case is equal to C1n plus C2 into n minus 1 plus C4 into n minus 1 plus C5 into n minus 1 plus C8 into n minus 1 is equal to what? C1 plus C2 plus C4 plus C5 plus C8 into n minus C2 plus C4 plus C5 plus C8 is equal to n plus b, where a and b are constant, is equal to linear function of n is equal to big O of n. It's done. I think it's interesting. This will be the form n plus b. So n plus b already yesterday we have calculated. Yesterday we have calculated that one for n plus b. That will be complexity big of n. Is it clear?
Yes, sir, it's clear. But wait for some time. We have to note. I want
This
to
is
note.
for the best case. This is for the best case. Now we have to come to the worst case.
Sir, 1 minute,
This is
1
the
minute.
best. Yes, yes. This is the best case. Okay, just let me share it in the reverse way. It will be more clearer in that case. Yes. I think this is visible.
Yes, sir.
So now you can easily understood that whether you have to write down the algorithm or not. You have to write down the algorithm. Otherwise, the calculation cannot be made. So in that way, complexities are there. You have just seen the complexity, what will be the complexities for sorting algorithm on data structure. But this is how we can calculate the complexities. Make it faster, Partho.
Sir,
Time
1
is
minute.
not there.
Last.
Yes, yes.
Yes, sir, yes, sir, yes.
We have very limited time and we have one gigantic size syllabus.
Yes, sir. Sir, one doubt is there.
Yes, yes.
Sir, in the first line, you have written C1N.
Yes, because this will continue in time. This is simple multiplication.
Yes, sir. Then there after minus there was in the second bracket C1 plus C2 should be there
Which one second bracket?
in the second bracket in the second line
C1
second
into n.
bracket.
No,
Yes,
why?
sir.
Why C1? C1 already we have taken C1 into n. This is simple algebraic
C1
notation.
into N.
So why this will be there in minus? Because
Okay. Yes, yes, yes. I
C1
got it.
into
Got it.
n, we are
Sorry,
taking
sorry,
the
sorry, sir. Sorry,
coefficient
sir.
of n. Yes.
Yes, yes.
So this has done.
So 1 second. Sir, move bit right. A and B are. So A and B are
Constant.
constant.
Sir, can you tell me once more C6 and C7 for one?
Which one? Which one?
Hello,
Ah, C6 and
hello.
C7.
Yes,
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 sir.
sir.
I can hear you.
Yes, sir. Sir, for one, for the best case, how we are calculating C6 and C7?
For the best case, if the array is already sorted, for each j is equal to 2, 3, etc. up to n, then we can find a of I less than is equal to key always. So why swapping? Why swapping? It's already sorted. No swapping is required. So why do you consider C5, C6 and C7?
Oh, okay, sir.
Tell me. Done.
Sir, can you show the page once again on last time for last time? Last part linear.
Is that clear? Because if it is already sorted, no swapping is required. For that, we have skipped C5, C6 and C7. Why this is required? Because these two
Yes,
steps are
sir.
only for swapping purposes.
Yes, sir. No swapping is there, therefore not
Exactly.
including
We
the.
have skipped these two.
Sir, little bit right. Little bit right. Okay, fine. Okay, sir. Noted
Okay.
down.
So now in the worst case, what will be the situation if the array is reversely sorted? If the array is reverse sorted, that means everywhere we have to swap. Everywhere we have to swap, isn't it?
Yes, sir.
If the array is reversely sorted, if the array is reverse order, then we have to compare each element, and everywhere the swapping will be there. Everywhere the swapping will be there. So in that cases, what will be the situation? We have to calculate that one also. The worst case. Start with that. Now, in the worst case, the array is in reverse order. So in that cases, what will be the situation? Tn is equal to, this is similar kind of thing, but we have to consider C5, sorry, C6 and C7. C1 into n plus C2 into n minus 1 plus C4 into n minus 2 plus C5 summation of j is equal to 2 to n j plus C6 into j is equal to 2 to n j minus 1 plus C7 summation of j is equal to 2 to n j minus 1 plus C8 into n minus 1 is equal to C1n plus C2 into n minus 1 plus C4 into n minus 1 plus C5 into n minus 1 by 2 minus 1 plus C6 into n minus 1 by 2. Because this thing already we have done in the bubble sort. Can you remember? I have already shown you
Yes,
n
sir.
into n minus 1 by 2
Hmm.
plus C7, sorry, plus C7 n into n minus 1 by 2 plus C8 plus 1 is equal to C5 by 2 plus C6 by 2 plus C7 by 2 into n square. If you are solving this one, plus C1 plus C2 plus C4 plus C5 by 2 minus C6 by 2 minus C7 by 2 plus C8 into n minus C2 plus C4 plus C5 plus C6 is equal to an square plus bn plus c. So here complexity will be quadratic equation is equal to a and b and c are constant. A, just a second. Just a second. So here this is quadratic equation. A, b and c are constant is equal to quadratic equation function of n is equal to big O of n square. So in the worst case, the complexity will become big O of n square. Visible or not?
Sir, can
Also,
you post in the group? It's not visible, that's why. The full thing is not visible.
yes, yes, yes. I'm just a minute. I'm giving you. What is that visible? Have you got it? Got it? Just simple
Yes,
multiplication
sir, I
and
got
then
it.
solution. Yes, that simple algebraic solution. The thing is that if the joining has not been made in time, then the problem is that I am not able to see every time the screen, isn't it?
Yes,
So I
sir.
will not be able to notice that one. Whenever I am coming into the WhatsApp, I am noticing someone is waiting, and again I am going back to that screen,
Sir,
and then
actually, the problem was the email. Problem was with the email. Ignus email
okay,
told that
don't
it
worry,
was
don't worry, don't
From
worry. I
10
will
a.m.
post.
class.
I will post it today. The total schedule I will post it in the group. So
Yes,
you
sir.
can
But
tell me then
when
if you told me
the
that
the
one.
email
Yes.
message contained the 10 a.m. link, that's why there was confusion.
Okay, okay, I will provide it. I will provide you the total solution at afternoon. Total schedule means we have two more classes. I will post it. This is 7 from today, and tomorrow it's I think from 7.
yes, sir, 7 p.m.
7 p.m. Yes. So, any question on the torch case? Otherwise, we will go to the quick sort and merge sort. Lots of things has to be done.
No, sir,
Lakhs
no
and lakhs
question.
of things. So this is one simple algebraic solution, but this is very important. You will find that one in the question paper. Almost in every alternative semester, this question was there. That how to calculate the complexity of insertion sort. And obviously, you have to go for this best case as well as worst case. Now, another divide and conquer. We'll here all these methods are greedy technique already we have done. Now we are going to another technique of algorithm, divide and conquering. Means first we will divide the elements and then conquering means merging of elements. Merge into, we will divide the elements into 2 subarrays or 4 subarrays or in that way. And then after sorting, we have to merge these items. So how this can be done? Let's start it with the merge sort.
Sir, sir.
Yes.
In the worst case calculation, in this
Yes.
C4 n minus 2 is there, and from in the second line C4 n minus 1 you have written.
Which one? C4 n minus 1.
Yes, sir.
No, n minus 2 nowhere is there. Actually, I got made some mistake on the first line also. This will be
Okay,
C.
okay, okay. C n minus 1 is there, no?
Yes, yes,
C4 n
yes, yes,
minus 1.
yes,
Okay,
yes.
sir. No problem.
Nowhere it's 2 there. I got them. I made the mistake.
Okay, sir. No problem.
Now, come to the merge sort. Acha, can you remember the merge sort? What was there in merge sort?
No, sir.
Actually, in merge sort, the precondition we can go for merge sort only in case of arrays are already sorted. If the arrays are already sorted, then only we can go for merging of these two arrays or 4 arrays, whatever. So, for example, Suppose these two arrays are there. Here you can already see that these two arrays are already sorted array. Here this is
Yes,
sorted
sir.
array, this is sorted array. Now here mechanism is first two items will be compared and whatever will be the smaller, this will come to the third array. Then 7 and 10 will be compared. Then 10 and 9 will be compared. Then 10 and 11 will be compared. In that way, this will be continued. So this is the merging. This array and this array will be merged together and it will create another sorted array. But
Okay.
suppose we do not have this kind of sorted array. We have one arbitrary array. Suppose as here in the previous examples, suppose we have this one 39, 9, 45, 63, this kind of thing.
Yes, sir.
So how this can be sorted in merge sort? How this will be possible?
Sir,
Here,
only one array is there.
one array. Then how this can be sorted? We have to breaks down. For that, this is called divide and conquer. First,
Okay.
we have
So
to
we have
divide it.
to
Break
divide
down
into two parts.
two parts.
Middle.
Exactly. 39, 9, 45, 63, 18. Suppose this one.
Mm.
Here, index is 0. Here, 1, 2, 3, 4. Sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This
Yes,
will
sir.
be 9. So
9
we
by
will
2.
calculate the mid value. 0 plus 9 by 2 is equal to 4. So 0, 1, 2, 3, 4. Up to that one will be one subarray, up to that one another subarray. Again here we will calculate in that way. The mid element.
Yes, sir.
0 plus this one is 0, 1, 2, 3, 4. So here 0 plus 4 by 2 is equal to 2. So 0, 1, 2. That will be divided. Again, if it is more than 2 element, so 0 plus 0, 1, 2. 2 by 2 is equal to 1. So here it will be divided. Now these two elements will be sorted first. So how this will be sorted? 39, 9. This will be taken first. 9, 39. Then 45 is already sorted. 45 is already sorted, one item. Then 63 and 18. It will be sorted in 18, 63. Now, if I can arrange this thing, these two will be merged. You can merge these two things as I have already shown you.
Yes, sir.
Then again, this two array and this array can be merged
Mm.
in that way. So we have to create that sorted array by dividing. And then we will breaks down into smaller subarrays. It will be either two elements or one element. We will sort the subarrays. After that, we will merge in that way. So for that, this is called dividing and conquering. Divide and conquer. Because first we are dividing the array, then conquering means merging.
Yes, sir.
Conquering means merging of
Merging.
arrays. Now, how the complexity? This is very simple one. I am coming to the complexity. How the complexities will be calculated. But before that, I think you are aware about the merge sort because algorithm is very important. You have to know how the merge sorting will take place. This is very important over here. Algorithm, whether I have to go for the algorithm.
So once, please.
Okay. Acha, in case of merge sort, I am providing you one illustration for that from the book. I am just posting it. See that one first. How the mechanism will take place. Divide by 2, divide by 2, divide by 2 in that way. First, the mechanism is very important. Once the mechanism is clear, everything will be clear. whether mechanism is clear.
Sir,
Just
first
now we
it
have
is
discussed.
broken down. After that
Yes, into
is
two subvariables.
sum is
Again
there.
breaks down.
Sum.
Again breaks down. Again breaks down.
Yes, sir.
Then merging,
Yes,
conquering.
sir.
Combine means merging.
Yes, sir.
So concept is clear. We'll
Yes, sir.
start with the algorithm on the evening. No issues. Just we'll stop over here and we'll take one again 10 minutes more on that class.
Sir, one question.
Yes.
Sir, is the time complexity different in case of if it is recursion?
No, all these are recursive way. All of these
Okay, sir.
methods are recursive way. We are not using non-recursive way. In case of non-recursive way, obviously it will take some extra time if we are following non-recursive way.
No, we always have to assume that we will
Generally,
calculate
exactly.
recursive way.
Yes. Generally,
Okay,
we
sir.
are using recursive way. Yes. So, okay, don't miss the class at 7.
Yes, sir.
Okay, chalo, bye.
Thank you, sir.
Thank you, sir.
Thank you.